Hello. Today we are going to talk about a programming problem named the traveling salesman. So, what is the traveling salesman problem? The traveling salesman problem is one of the most famous mathematical problems in programming. The problem aims to find an algorithm that will calculate the shortest path of a salesman traveling through n cities. It's known that no polynomial solution has been found so far. Different algorithms can be used to solve this problem with different ways. But we will use dynamic programming to solve the problem. In this video, we will try to explain that easy yet very amusing problem.
So, at the beginning, we have one salesman and n cities. Assuming the salesman is already in one of these cities, there are n-1 factorial different paths to travel n cities and return to starting point. In order to make indexing easier in code, we will select the salesman starting location as city 0. We work with 4 cities to make learning and teaching the problem easier. On the screen, you can see 4 cities and their distance from each other. The salesman starts from city 0 and comes back to his current location. Starting with the first example, he simply goes to city 1 by crossing 15-unit path, then to city 2 by 35-unit path between 1 and 2. Afterwards, he goes to city 3 by 13-unit path. At last, he uses 20-unit path to return his starting point. In total, he travels 95-unit path. However, there could be a shorter path, and there really is.
Let's have a look at the second example. The salesman chooses a different path, goes to city 2 first, then to city 3. After city 3, he goes to city 1, and finally, he draws an hourglass by returning to the city 0 again. By using this new path, he only travels 80 units. That is 15 shorter than the first path. But still, could it be shorter? In the third example, salesman now chooses another path by going to the city 3 at the beginning. Then, he goes diagonally and reaches city 1. After that, he goes downwards to the city 2, and eventually, he goes diagonally again to arrive in his starting point, city 0. And that draws a beautiful butterfly, or a clockwise rotated hourglass, you may say. And what is the cost in units? It's 95 again, and it is longer than the second example.
We can look at these 3 examples separately and find the shortest path. But considering that there are n-1 factorial paths, and as n gets larger, visible solutions will disappear, and there will be a lot of examples. It's clear that we need to code this with an algorithm. We can see that it's an iterative problem. So dynamic programming would come in handy for solving this problem. Why? Because dynamic programming is nothing but a recursion problem with memorization. That's what we need. Trying every path, remembering the path with minimum units in every try, and eventually calculate the minimum units possible. In our project report, you can find the code for its solution and its detailed explanation. In this video, we hope that we explained the problem clear enough.